So we know average rate of change, delta y over delta x, usually some sort of distance or measurement like length or area over time, but it doesn't have to be over time. F of b minus f of a over b minus a. And we know when they say estimate the rate of change or estimate slope, anytime we see the keyword estimate, they're talking about average rate of change. So estimate rate or slope. These are words to mean find that average rate of change. Sometimes they'll outright say average rate of change, but most of the time they'll use the more vague words like estimate. So instantaneous rate of change, we do know the limit formula, but now we also know that when we're talking about instantaneous rate of change, we're really talking about the derivative. So anytime it says instantaneous rate of change, we're talking about derivative. So let's look at an example. Let's find the rate of change of the area A of a circle with respect to its radius r. So most of the time when we've been working with this instantaneous rate of change, we've been comparing the rate of something over time. So how is the radius changing over time? Or how is the distance the person is from 0 changing over time? But this time we're comparing if I have a circle and my area is changing, how does the way the area changes compare to the way the radius is changing? So first we need an equation. What equation should we use if we're talking about area of a circle? Pi r squared. You know, area is pi r squared. Well, we can find the derivative of this with respect to the radius. It's saying to find the derivative of the area because they say rate of change, which means derivative. Of a circle with respect to its radius. Well, over dr, remember the top tells us what's the derivative. The bottom is what are you taking the derivative with respect to? What variable is the one we're actually taking the derivative of? So we're taking the derivative with respect to r. So what would the derivative of this be? 2 pi r. It's just a power rule problem with a constant in front. If we bring 2 in front, 2 times pi times r, we do 2 minus 1. We reduce everything and we get just 2 pi r. Which is kind of cool because what other formula is this for a circle? Circumference. The derivative of the area gives you circumference. Same thing happens with the sphere, the volume of the sphere. If you take the derivative, it gives you the surface area equation. So they're actually related. I know. I'm a witch. So what if I want you to actually evaluate the rate of change? I want to know what's going on with how the area is changing when the radius is 5 or when the radius is 10. So what should I do if I want to evaluate the rate of change? What do we usually mean by evaluate? Just in general. If I said evaluate f of x at x equals 5, what would you do? Plug it in. Find y by plugging in 5. Well, same thing here. Evaluate usually means plug it in. Usually. So we know when the radius is 5, the area is changing at a rate of 10 pi. What would my units be? We're doing dA over dr. So we always look at this to kind of help us with our units. What do we measure area in? Square inches or square units. What would we measure the radius in?
If it were inches,
Yeah, so if it were inches, it would be inches, or we can just say units. Now, normally, we can cancel stuff out. We have square units over units, we could cancel it out and just have units. But since we're dealing with rates of change, we want to keep the units exactly how they are because we know we're trying to compare how is the area changing to the radius. So right now the area is changing at 10 pi square units compared to 1 unit of radius. So then we could do the same thing if we're trying to find r equals 10. You can plug in 10, so 2 times pi times 10 is 20 pi. And it'd be the same units because you're still using the same formula. But now at 10, your area is changing more quickly. 20 pi is a lot bigger than 10 pi. The rate your area is changing is quicker because you have a larger radius. The larger your radius gets, the faster your area changes. It's kind of like, do you ever, maybe it's just because I'm a nerd, do you ever try and figure out when you go to pizza places and the pie, and they say, our pizza is 16 inches in diameter, and I'm like, well, what about the area? Because that's what I'm actually eating is the area of the pizza. So you try and compare the area to the cost. Okay, no, you've never done that. Because I want to know, is it really better to buy the extra large pizza that's ginormous, and am I really saving money overall? So the larger your pizza gets, when I did that, then the larger your pizza gets, diameter-wise and radius-wise, the faster your area increases. So it is a better deal to buy a larger pizza. Because you get more area more quickly when they increase the radius. Wait, what kind of pizza is better? Because there is no pizza better than the pie. Oh, bigger pizza's better.
Yeah.
I thought you were saying a different brand.
No. No.
Okay. So example 2, I just really.
That's a lot of words.
I know.
Welcome to English class.
Oh.
Out of English, thank you very much.
Really, the first part is so that I could have it in words and I didn't get my words confused. Because sometimes when I try and talk and think at the same time, it comes out wrong. So really, you just need to write from say on. So sometimes when we're trying to work with these geometric shapes, we want to compare certain pieces of our objects. Sometimes we have multiple objects together, or sometimes, say we have volume of a cylinder. We have both radius and height. So when we're taking a derivative, at least right now, we can't have 2 variables. We can't have multiple variables, or sometimes we just want to see how is one thing changing in comparison to another thing, and we want specifically radius of the circle instead of side of the square. We want to know information, but the formula we have, we might have to rewrite because it's not written in terms of the radius. It might be written in terms of the side of the square, and we want the radius. We want to compare radius to area. So when we want to compare certain specific pieces, then sometimes we have to do some geometry. So we have to think back to geometry class.
Isn't it like second grade math one or something?
Now geometry is kind of put into all the different math classes. Secondary math 1, 2, and 3 all have some geometry in it.
Both still geometry.
Um,
Kind of like World War II after all the countries got split up.
well, it's like they took 4 years of math and put it into 3.
It was kind of dumb.
Yes.
Moving back.
So you guys know what inscribed means, right?
It's inside.
It's inside and it's actually touching the edges of the outside shape. Like if I just drew a random square in here, not inscribed. It's just inside a circle. Inscribed means they've got to be touching somehow. Or circumscribed means it's the outside shape. The circle is if you have a circle circumscribed around a square, it means the circle is outside.
So where would the circle be touching the square?
At these vertices of the square. We could inscribe a circle inside a square where it's touching, but
Okay.
So we want to see how the area of the square is changing compared to the radius of the circle. So we want first a formula for area. We need to start there, but then when we go to take the derivative, we're going to say, oh wait, I don't have radiuses involved at all. Let's just start with area. 5 a square. What's area of a square? S squared. We know area is S squared. That's the equation for area of a square. But our goal is to find dA dr. It said if we want the rate that area is changing compared to the radius. That's a problem because I don't have any r's. All I have is s. So somehow I have to relate r and s together so that I could replace s with some version of r. But it has to follow mathematically correct principles. I can't just say s equals r. Are these the same length? No. So we need to know some geometry in order to do this. So what is helpful is if we increase this to be the diameter. What would the entire length of that side be then? Of the diagonal, I guess I should say. 2r. And what do we know about squares? What do we know about the angles inside a square? They're all 90 degrees. So now, what shape do I have?
Triangle.
Specifically,
45,
45, 90 is even more specific, but I was looking for right triangle. You are both correct. And what do we know about right triangles?
The sides are the same.
Close. These two sides are the same, but I'm having one of those days. How can we compare all 3 sides? It's a theorem that starts with C.
Pythagorean.
Pythagorean theorem.
Oh.
Pythagoras discovered this for us. So I could say s squared plus s squared equals 2r squared. So now I need to do a little simplifying. Since it's a square, s squared plus s squared, I can write as 2s squared. 2r squared, we have to square both. 2 squared is 4, r squared is r. And then I need to get rid of the 2. So now we're just down to some algebra. Divide both sides by 2, so we get 2r squared. Now I could square root this and plug in for s. But I could also just replace s squared right now. It's substitution that you're probably not used to seeing. Usually you get just s equals something, or x equals something, or y equals something. But if this and this are exactly the same, let me highlight what I mean by this and this. If this and this are exactly the same, I can replace the entire thing with 2r squared. So now I know the area is 2r squared. And I can take the derivative with respect to r. And we wanted to find dA dr. So what's the derivative? 4r.
4r.
So today I want to hopefully get our assignment done before the end of class.
Yes.
We only have
that'd be
15
awesome.
minutes.
Well, that'd be like so cool. Like,
So you should just like give us 3 problems
yeah, like 4.5 problems would be great.
and a half.
Why did you pick that color? No chance.
It's just still on highlight,
Because
so
that's one of the
I
ugly
could do calligraphy.
yellow mustardy
Oh, that looks so cool.
Oh, look how much
I was
nicer
getting
that
fancy.
looks than the- Wait, that's
Page.
peas?
Page.
Page.
No, I get the brown. I'm just wondering if
The grandma, she's born.
I don't know.
No, she just kind of went.
Oh, I just squiggled after because I was surprised it was
Oh.
highlighter instead of
No,
pen.
that says page.
It started out P and then I was
I was
like,
gonna say popular mechanics.
135.
Yes.
PM.
Really cool. I know, I like it. You should keep it like that.
Wait, what are you talking
The
about?
calligraphy.
Are you okay?
That made me dead.
Yeah, I heard a slamming of the desk, but I don't know.
Oh.
Each question has an A, B, C, and D.
I almost.
I was like, that's
Almost.
I'm almost
like I
cried
said.
tears of joy.
Crushing dreams.
Oh, I almost,